Hi, I'm Emily, and this is Annie, and we're here to present our final project for ENGI 1410. We're improving a model that classifies X-ray images for patients and determining whether they have pneumonia or not.
For the baseline architecture, there's one convolution block with 16 filters, a 3x3 kernel, and then ReLU is applied. And then after that, it goes through max pooling of 2x2. And then it gets fed into a network with 64 neurons, and then ReLU is applied again. And then for the output layer, it goes through softmax, and then for the loss function, it's cross entropy loss. So this is our baseline model. As you can see from the metrics, the accuracies are already quite high for all three categories with the training, validation, and testing. The only issue is that the model is overfitting because the training accuracies are really high in comparison to the validation error, which is a 3% gap, and you can also see that in the validation and the training loss. So this is the accuracy curve for the baseline model, and as you can see, starting from around epoch 6, the gap between the validation and the training curves, it widens, which indicates that there is overfitting. And then this is the curves for the loss, for the validation and the training. And as you can see, the same thing also happens. Around epoch 6, the gap widens.
Because we noticed overfitting, in our final model, we decided to increase the number of convolution layers from 1 to 3, change the kernels from 3 to 5 for all layers, and then we introduced L2. The reason why we increased the number of convolution layers was because that every convolution layer introduces 2x2 max pooling, and even though the model got deeper overall, the pooling reduced the spatial dimensions and decreased the number of flattened features. And then we chose to introduce L2 because it penalizes large weights, and this reduces the impact of very strong weights on the model, and it generalizes better because of that.
So this is a comparison between our baseline and our final model. So on the left, you can see our baseline accuracy curve, and on the right, you can see our final accuracy curves. And you can tell that overfitting has improved for the final model because the gap between the validation and the training curves are like really small. And in general, the numbers themselves are higher for the accuracies for the final. And you can see pretty much the same situation in our loss curves. On the left is our baseline, and on the right is our final. And over here, the gap is pretty much non-existent, and also the numbers themselves are lower for the loss.
Yeah, just to conclude, a key takeaway that we got from this was how important it is that a model generalizes well, especially when we're dealing with the CNN that does medical imaging. If it's put into real-world situations and used on unseen data, it's really important that it's accurate and it's confident in its results and classifications, especially because there is a lot of real-world stakes involved with the healthcare sector and people's lives.